It's me. We're going to jump right into finishing that sheet, that handout that we started working on. Here it is. Okay, hold on. O'Reilly Auto Parts. So we did all this work. So this is the one we did a while back. This is the one about the dolphins and all that kind of stuff. And then we got to the backside about people talking about voting. And we still have to do this part here. What I want to do is show you where this equation comes from. Now, pretty much, all right, people are still coming in. So let me sort of slow down here. Let's see. Goodbye. Hello. All right, guys. So can somebody tell me in this equation right here, what is the error? Which part is the error? Error.
Anything after the plus or minus.
I love it. So this is the error. So if we scroll down here, you'll see I've identified that as the error. I like it. All right. By the way, well, all right, I'm not sure if I should really talk about this, but is anybody watching that there's the trial happening right now? Does anyone know there's a certain trial happening right now?
Is it the George Floyd one?
Yes, the George Floyd murder trial. So for some reason, I keep watching it, and it's disturbing to say the least. But now anyway. Sorry. So it's in the back of my head, the presentations they're doing. So I feel like as I'm teaching, I feel like I'm in front of a courtroom. But we proved this equation. Where'd you go equation? This one. We proved that one together. I have no idea if you guys remember. We had to solve for n. So here, can you imagine if I wanted to solve for n, wouldn't I have to square? See the squares? Wouldn't I have to multiply the n up and divide the e down? So, I mean, I'm not going to do it. So there it is. This is the formula I would use if the question said something like, how many people or how many things or how big of a sample? Because that's what n means, is the sample size. So it kind of makes sense. That's the formula I would use if they're asking me to figure out a sample size I need. Now, here's the tricky part. If you read through 2A, somebody tell me, oh man, people are still coming in. What time is it? Come on, people, get here. Can somebody tell me what E is? If you read through this 2A. What is the error? Anybody? There's a certain magic word that won't always be used.
I think someone said it in the chat.
Oh, shit. All right, this thing used to alert me when I got chats, and now it doesn't. Oh, I see. Somebody's telling me that their mom is watching the trial right now. Okay. Okay, thank you. So somebody did say in the chat. So this is not going to always be used, but it is very, very often used. And it kind of makes sense. This is something, give or take something else. So the error tells me within how much I think the real percentage lives. So the word within makes sense. So the error, don't put 3, because 3% is 0.03. All right, so I know what the error is. They have to tell me what the error is. Do I know what the z-score is? Is there a way to figure out what the z-score is going to be for this problem? Which part of the question tells me how to get the z-score? So for example, why did we use 2.05 up here? Does anyone remember? Why did we use 2.05 up here?
because it was outside of the 0.96 or 96%.
So the level of confidence tells me how to find the z-score, because the level of confidence deals with how much stuff I catch. And how do I catch more or less stuff? I go more z or less z out from the mean. I really want this to make sense. That's why they're directly connected. The level of confidence I want to have is directly connected to what the z-score needs to be. Now let me say a phrase: baby chart, not baby shark, baby chart. Does anyone remember what baby chart reference is? Can you find the 99% confidence level very quickly using the baby chart?
1.645.
Uh-oh, no, that's 90. I want 99.
2.575.
There we go. Is anyone not able to find that? Can you guys all find this? Or you can't, and for some reason you don't care, I guess. So everybody can find that. That's what I'm going to assume. Okay. So what else do I need? So I have this. Check. I have this. Check. What are these? All right. Here's a throwback. What are those? All right. So that's kind of like what I'm trying to hint at here. If you don't know the percentage of something, what's your best guess? So like, what's your best guess for the percentage of women that are in Kentucky? The percentage of people that are women in Kentucky. What's your best guess?
50%.
50%. I love it. So if the problem doesn't tell you what these are, you guess them to be 50%. All right, now stay with me. Stay with me. Here, let me turn this off for a minute. All right. That formula we're working with tells me how large of a sample I have to take to be 99% confident. If there's something I don't know, should that force my interval to get larger or smaller to cover for that fact? If there's something I don't know, should my interval have to get bigger or smaller to cover for that?
Bigger.
Bigger, of course. Does that make sense? I like to think of it as I got to cover my ass, so I better make it bigger so it covers my ass, right? And again, sorry if you're offended, but too bad. So it's a nice way to kind of remember. It makes sense. There's something I'm not sure about. I don't know what p hat and q hat are. So mathematically, stay with me. If I make p hat and q hat 0.5, that makes n the biggest it could be. So kind of, if there's something I am not sure about, then my sample size should have to get bigger to compensate for that too. All right, so I want this to make sense in a few different ways. If there's a percentage you don't know, your best guess is 50%. I don't know, it's 50-50. I have no idea. What's the probability that that guy over there turns left down the road? 50%. I have no idea what the hell he's going to do. Does that sort of make sense? And mathematically, it makes n the biggest it could be. So that's sort of like us punishing ourselves for not knowing something. All right. No idea if you guys are with me. So to figure out how large of a sample I need to be within 3%, I can throw into the formula now what my z-score is. I'm going to assume that p hat and q hat are both 0.5, 50-50. And then I want to be within 3%. The most common thing people make a mistake about here is to forget to square stuff. So throw the old calculator. Let's see what we get. All right. Let's see. Does anyone think they have got the answer? right? And real quick, where did all this stuff come from? That's how confident I want to be. That led to that z-score. That's what I want to be within. That's the error. I don't know what these are, so I guess 50-50. So that's where all that stuff came from. Does anyone have the answer yet? Can you put that in your calculator?
There's
Put
an
that.
answer in the chat.
Oh, shoot. Oh, man, you guys are funny. So when I'm sharing my screen, for some reason, Zoom updated, and it does not tell me when you're chatting at me. I'm really sorry. It used to. 1841. Yeah, that's the right one. Yeah, it's almost right. There's one little thing wrong with this. I don't want anybody to go out in the world and get 1,841 people and then chop a little bit off of some other person and say, I only need 84% of you. Chop, right? I'm not going to create a bunch of Dexters to start running around, if anyone gets that reference. So whenever I do this, whatever this is, if it's a decimal, I'm going to round it up. So I need 1,842 people. Oh, here come the helicopters.
So when you round it, it doesn't mean does it any decimal like goes up to the next number? So if it was okay. So even if it was like
I got 701.02, right?
uh-huh.
So that would mean that I would need at least this much to be as confident as I want to be. So if I go down at all, I'm not confident enough. So I always go up.
Okay.
Yeah. All right. So that was just an example in case somebody gets all freaked. Where'd you get 702 from? Be quiet. Now, what's different in part B? I still want to be 3% within 3%. I still want to be 99% confident. I gave you more information though. Have you guys ever heard the phrase preliminary study? This phrase? Anybody? Does that sound at all familiar to anybody? We did a preliminary study. Anybody heard the
Yes.
preliminary? All right. Somebody's like, just somebody say yes to shut them up. I'm like, all right. So the reason we do these, now watch, what information can I get from this? Look what I found. Right? This is all about students passing statistics the first time around. So I talked to 42 stat students and 31 of them passed the first time around. What can I calculate from that? Somebody trying to tell me something or what's happening? Somebody, oh, good. Whoa. All right, there we go. All right. Hello? What can I figure out from that?
P and Q.
Yeah, well, P hat, what's P hat? How would I figure that out?
That's the positives, right? So it'd be 40. No,
How many passed?
42. No, 31.
31 out of?
42.
There you go. That's how you always do a percentage.
Right.
Okay. 31 out of 42. So up here, did I know what P hat and Q hat were? No. So I had to guess. I had to guess 50-50. Now with the preliminary study, I know what P hat is. So help me out. What does that come out to be? 5 out of 7, 14, 0, 2, 70, 0.72. I don't know. Trying to do that in my head. 31 divided by 42.
Point
Oh.
561.
Do who to what? I get
Point
738.
561.
I get 738.
Oh shit. Hold on.
Yeah, total shit. All right. And what's Q hat then if that's 0.738?
42 divided by 31.
What? What? All right, today is a really interesting day so far. Say it again.
There.
I got 0.262.
Okay, sure.
Yeah.
Thank you. I don't know what's happening. So now I know this is brand new. Up here, we had to guess the percentages, and the best guess was 50-50. Is everybody with that? That kind of makes sense. Our best guess is 50-50. Now we don't have to guess anymore. I'm going to set up this exact same formula, but I don't have to guess 50-50. I know what the hell they are. And let's see what happens to the required sample size. All right, so throw that in your calculator and smoke it. Tell me what you get. Oh, in my calculator. Let's see. Bam. Oh, since my baby left me, got a new place to dwell. It's way at the end of a lonely street now. Anybody? I'm gonna keep singing. You want me to keep singing until somebody tells me the answer? That's horrible. That's cruel.
1,425? 1,425?
Nope.
7,576.38.
No.
No? Okay.
All right, let's see.
I got
14,245.
Interesting. You're off by a decimal place. I don't know what's happening.
0.2.
All right, so the correct answer is 1424.5 blah blah blah. So round it up to 1425.
Oh, that was the answer I said.
Okay. All right. It's not what it sounded like, but okay, if that's what you got, good. So I need over 400 fewer people since I did that preliminary study. So that's why those are done. That's one reason why they're done. So I want you to really understand. If I know ahead of time I want to be plus or minus 3%, I can use this formula to figure out how large of a sample I should take. Are you guys with me? I also call this a feasibility study. What the shit does the word feasibility mean? Anybody? Feasibility, feasible. Feasibility? Anybody ever heard that? You just made it up, Jeff. I don't want to play Scrabble with you, Jeff. Making up words. Anybody ever heard the word feasible? That's not feasible. Is it feasible? All right, feasible means, is it something that we're able to do, that we have the resources to do? So as a class, if we did this formula and it came out with, we had to talk to 90 people, is that something we could do? Could you talk to 90 people? Yeah, even now it's harder because of COVID, but still we could talk to 90 people. If we did this formula and it came out to 3 million people, do you want to talk to 3 million people? No, we don't have the resources. That would not be feasible. So when I do this formula, I see how large of a sample I will need to take. Have we ever had something like that before? No. We just know a bigger sample is better. That's all we know. But now we have more specifics. Dependent on how certain I want to be. I want to have a 3% error. Well, that means I have to have this many in my sample. If I do a preliminary study and get more specific information, I have a more specific number. I don't need as big of a sample anymore because now I know more. All right, maybe. Okay, all right. So that pretty much finishes section 8.3. Okay. Any questions from this? So we did this part last time with the little formula that we created last time. It's got the same kind of conclusion to make, right? And now here's the how to figure out how large of a sample you need. Okay. All right. Okay. So one more section to kill chapter 8, right? Or to finish chapter 8, if you want to be less Games of Thrones about it. So hopefully I didn't freak you out when I said I want to do section 8.2 last in chapter 8 because it introduces a new chart. So let's talk about this. Let me turn off my Earth and Moon. Oh shit, I turned off everything. All right. Let me turn off my background. Where are you? Here we go. Oh no, it's blurry. Okay. All right, guys. Now it's your time for your favorite stuff. It's Uncle Jeff's concept time. So this is where we talk about the idea behind what we're about to do. Before we do what we're about to do, I'm trying to get it to focus better. All right. So here is the formula for a confidence interval for a mean. Why is this so dark? Oh yeah. One more light. I have lights everywhere. Oh yeah, okay. So here is section 8.1, confidence interval for the mean is this guy. I have no idea if you remember this, but the whole thing that chapter 8 is predicated on, is this idea that we normally don't know this. We don't know this. So chapter 8 is kind of like our first attempt at, the word just escaped me, estimating what mu is, right? So I get a sample mean, which is itself, I really want this, the sample mean is an estimate for the real mean. Is that cool? That's something that we've sort of talked about this whole semester. The sample mean is an estimate. Is it a good estimate? So doing this kind of improves on that estimate. It gives more information besides just one what's called point estimate. If you've seen the phrase point estimate in the book, that's what it's talking about. Either X bar or P hat. It's the sample information. That's a point estimate. Okay. Now, I think I alluded to this. Ooh, look at all these words I'm using today. I alluded to this in the first place. We normally don't know this, so we use this instead with some help, but we also normally don't know this. I mean, if I found a new species of, don't ask me why this is in my head. I have no idea. A new species of spider, right? So do we have any idea what the average weight of this new species of spider is? No, we just found it. It's a new species of spider. So do we know anything about the standard deviation of the weights of this? No, we don't have a clue. So normally, not only do we not know mu, we also don't know sigma. What's the next best thing I could do if I take a sample? What could I use in place of sigma? What's the point estimate for sigma? What can I calculate from a sample? Well, if I don't know mu, what do I use? X bar. And X bar is the what? What's X bar? What is it? What is X bar? What is X bar?
The sample average.
Good, the sample average. Kick ass. So if I don't know the population standard deviation, what's the next best thing I can use? If I don't know the population mean, I use the sample mean. That's my next best thing. If I don't know the population standard deviation,
population sample mean.
That's a neat trick. It's population sample, they don't go together. If I don't know the population mean, I use the sample mean. If I don't know the population standard deviation,
Sample
Use
standard
the
deviation.
sample standard deviation, yeah, calculate S. And all right, so stay with me. The thing I like about this is we just talked about this earlier today. If I don't know this and I have to use this instead, and I want to plug that right here, I want to put it right there because that's where our standard deviation goes in our formula, right? Is there something in my formula now that I am not certain about? If I put that there, if I put an S up here, is S definitely equal to sigma? Does S equal sigma? Would you put money on S equals sigma?
No.
Hell no. I put money on the opposite. I put a ton of money on a sample standard deviation not being equal to. Are you guys with me at all? Like if I took a sample mean, is it going to be the same as the population mean? Almost definitely not, right? Will it be close? Probably. It needs to be, yeah. Especially if you take a bigger and bigger sample, it should get closer and closer. But will it equal it? No. All right. What the shit am I talking about then? So should our confidence interval, to make up for the fact that there is something in my equation that I'm not certain about, should my interval have to get larger or smaller?
Larger.
Yes, I should have to catch more shit if I am less certain about how spread out everything is. It's kind of like a punishment for me, right? Yeah, I like it. I always think of I'm gonna whip my So the really freaky thing is I can't do anything with N. That's just the sample size. But instead of using a Z-score, I'm gonna use a score that's always a little bigger than the Z-score would have been. Let me say that again. One way to make our interval wider is to make the error bigger. That's going to make it go more up and more down. Yes? So if I use a score that's always bigger than the Z-score would have been, that'll do it, won't it? And we call it a T-score. Oh shit. So, nifty little side note. Does anyone drink Guinness? Out of curiosity. You obviously don't have to tell me because it's a personal.
Yes.
Does anyone know what Guinness is? Anyone ever heard of Guinness? Yes?
Beer.
World records in beer.
It's like a beer. One of my favorite comedians said it's like a beer, but they decided to put a whole pot roast and mashed potatoes in the beer too. It's like I don't know. That's a good description of it. Personally, I don't like it that much, to be honest. I used to drink some with my physics professor after class to get on this good side, because he would go and he'd say, "Come with me there if you want to talk to me." And I'm like, "Get a Guinness," because he's drinking Guinness.
You don't do that?
Huh?
You don't do that now?
I don't take my students out. No, that was university, so it was actually grad school, so it's a little bit different. I guess I don't know. All kinds of weird shit happen, but so all we're gonna have to do, I'm gonna do everything the same way we've done before in section 8.1. It's just that when I go to look up what goes here, I use a different chart. Now let me ask you this. Stay with me. Does everybody get the idea, sort of?
Check out the comments. That's why we're laughing.
There it is. All right, let's go get a cold one, watch some anime. I like it. What else did I miss? I'll drink with you. Oh, okay, sure. All right, I like it. This is America. we drink for whatever. We're like, Cinco de Mayo, we have no idea what the shit that is, but we'll drink. Sure. I mean, yeah, that's America basically summed up. Am I saying there's something wrong with that? Not really. So the whole purpose, the whole reason this, oh yeah, that's right. I'm sorry. Let me tell you why I brought up Guinness. I forgot. I totally, what am I drinking? It's not Guinness. I'll tell you that. It's got a kick. The person that came up with the T-score chart was a guy that worked for the Guinness brewery. And the word brewery is one that'll make you sound drunk. He worked for Guinness. He was doing research on, to be honest, I forget exactly what the research was, but he wanted to publish it. But since he worked at Guinness, they had control over any research he did. So he submitted it under a pseudonym, under a fake name. And he used the name Student. So it was this T distribution that he kind of created, and he called it the Student's T distribution. So not a very exciting story, except for it's connected to booze. Look at can you tell I cut my own hair? Jesus. All right. Now, yeah, I need a better barber. That's for sure. Now, stay with me. We just agreed earlier that if I get a sample standard deviation, I'm almost certain it's not going to equal this, correct? And that's why we need this to kind of make my interval bigger. The larger the sample I take, how does my confidence in S change? Does it change? If I take a bigger and bigger sample, how certain am I about how good S approximates sigma? Does it get better or worse if I take a larger sample?
Worse.
It gets better.
Of course it gets better. Everything gets better in statistics with a good random large sample, right? The bigger the sample, it's got to be random, but the bigger the sample, the more confident I am about what I see. So what we should expect is that this T-score will depend on how large the sample is. The larger the sample, the smaller the T-score can get. It'll start getting closer and closer to a Z-score. Okay, so let's take a look at this. Oh shit, there's one more thing. Oh God. All right, there's always one more thing. All right, this is gonna come out of left field a little bit. Just go with me. It really is. You ready? It's gonna totally come out of nowhere. If I have 3 numbers and I know they average to be 10, can you tell me anything about any of the numbers individually?
They could all be the same.
Sure, but they could all be different. So can you tell me anything about the 3 numbers? For sure, anything individually? No, you can't, right? But now if you think about it, you can tell me what they have to add up to be. If 3 numbers average to be 10, what must they add up to be? Sounds like a puzzle. How do you average 3 numbers? What do you do? Tell me. How do you average 3 numbers? How do you average 3 numbers?
Add them up and divide the sum by 3.
Add them up and divide by 3. What would you have to get them to add up to be so that the average is 10? So you add them up, divide by 3, and you get 10. So then, therefore, what must they add up to be?
30.
30.
30. Okay, I love it. So if I know 3 numbers, average to be 10, I know they add to be 30. Each one can still be any frickin' thing in the universe as long as they add up to 30. So let me put my 3 numbers. Here's 3 numbers. Somebody give me a first number. Anything.
100.
100. Kick ass. Somebody give me another number.
12.
12. All right. What do these add up? Can I ask you for any number for the last one and still have an average to be 30? Can we just make up whatever we want to? No, now we got to get serious, right? What does this add up to currently?
112.
112. So what do I need the last one to be so it adds up to 30? I'll give you a hint. It's negative, right? You can do it.
82. No, I mean,
If you don't believe me, take a minute. Add these up. What do you get?
30.
So when you divide by 3, you're going to get an average of 10. You guys going with me? So remember, numbers can be negative. Nobody ever said they're not negative. Okay, I like it. So how much freedom, if I have 3 numbers, how many of them was I free just to make up without thinking?
2.
2 of them. If I had 28 numbers, how many could I just make up? If I had 28 numbers, how many?
27.
27. Does that make sense? It's that last number that I go, oh shit, the party's over. All right, we got to be serious now. Let's figure out. So if I have n numbers, how much freedom, and we'll call it degrees of freedom. You could do it. With 3 numbers, I had a freedom of 2. With 28 numbers, I had a freedom of you could do it, Jeff, 27. So with n numbers, how much freedom do I have?
N minus 1.
Minus 1. So that's so excuse me for this. That is my degrees of freedom. Does anyone get that? It's the degrees of freedom. Oh, sorry. It's
Mel Gibson.
sorry.
It's Mel Gibson.
I it sounded like you said smell Gibson. All right. Sorry, I appreciate it. Good old smell Gibson. So let's look at this weird ass chart, and then we'll try some problems, and maybe we'll have an early day because Jeff is tired. Let's see. I'm gonna make this chart. So there's going to be a T-score chart. There it is. It is in Unit 8. So if you go to, where am I? Go to Canvas right now. You will see this T-score chart. So let me show you. Let me become a student so it looks the same. Student. Scheisse. Oh yeah, Unit 8. There, see it? T-score chart. How? But look how beautiful that is, poor little thing. Look at that little thing. Look at that. He's so beautiful. All right. So is everybody able to go get that sucker? T-score chart. Look over here. See how it says degrees of freedom? Degrees of freedom. So if I had a sample of 7, where would I stop? If my sample size was 7,
6.
6, I would stop here. And now we got to talk about how to know where to go here, but all right. So let me open this a different way because oh shit, people are chatting at me. I can't do that, guys. All right, hold on. Let me open this a different way so I can access it a little bit better. So I think, do all of you guys have it? You all got the T-score chart? T-score chart. All right, where are you? Let's see. Oh man, here it is. Okay. It's gonna be really fun when I just finally go fully insane. I'm gonna have a ton of fun with it. All right, here we go. So let's take a look at this sucker. Let's see. How in the world do we read this freaky ass thing? So let me ask you this. All right. There's a really, really good reason, an unbelievably good reason. We're going to learn it very quickly in chapter 9, why this is set up this way. Look, area in one tail, area in 2 tails. What the shit are they talking about with tails? Can each of you please draw right now Draw a 90% confidence interval for me, please. Just draw it. All right, let me see. Does somebody want to share their drawing? I'm curious. Anybody want to share their drawing? Or are you guys just drawing a duck? What's happening? I'm going to do something, make it look like I'm working on what he said. Anybody want to share what you did? No? All right, I'll do mine. Fine. Oh, wait. Somebody's showing. Hold on. Hold it right there. Hold it right there. Oh, there we go. I can't see it, buddy. Oh, there it is. Okay. That's acceptable. I like it. All right, so let's do this. Thank you for playing along. All right, so let me show this. So 90%, any confidence interval for that matter, but 90% confidence interval looks like this. Is that cool? And that's why it's got a plus and minus, because it goes down so much and it goes up the same amount. That's why it's plus or minus in the equation. Cool? How many tails did I just create when I drew those lines? How many tails did I make?
2.
2. Damn straight. So this is a 2-tail situation. Can somebody tell me what area is in the 2 tails?
The remaining 10%.
Yes, 10% the 2 tails. All right, Jeff, calm down, dude. The symbol, dude, you're still, take it down a notch. The symbol for area in a tail or tails is the Greek letter A. Does anyone know what the Greek letter A looks like? Kind of makes sense. Area, right? So we're going to use a Greek letter A for area. It looks like a fish. It's the little fish dude, right? You guys all seen that symbol? Little fish dude symbol? It's an eyeless fish. So just, feel bad for the poor little thing. He's fine. So I would say alpha is 0.10 for a 90 degree. Where is that coming from? 90% confidence interval. Okay. So now do you guys, oh, sorry, go ahead.
Are you saying that area is also called alpha for this, like just this part of the chapter? Or are you saying in general, like alpha can be area?
In general, if I'm talking about the area in the tail or tails of a situation, that's alpha. Right now, confidence intervals always make 2 tails. You guys agree with me? Confidence interval, because I chop off the middle, it's going to make 2 tails, correct? But now watch this. If there's 10% in the 2 tails, how much is in the 1 tail?
0.5.
0.05, 5%, right? Which
Yes.
column am I looking at? 2 tails, 10%, correct? Which column am I looking at? 1, 2, 3, 4, 5. Which column?
4th column.
4th column. Everybody with me? 10% in 2 tails. Well, what's 10% in 2 tails? It's also 5% in 1 tail. Do you guys, either way you look at it, you end up looking at this column. All right, so if I wanted to create a 90% confidence interval and I had a sample of 7, what would the t-score be? So I know I'm looking here. You with me? 90% would mean 10% outside. And then where do I stop here?
On 6.
On 6. I love it because the degrees of freedom, Jeff, I'm going to do that every time, and I apologize, is 6, right? N minus 1. So I'm going to be
1.943.
1.943, kick ass. And look, like I told you, what happens as my sample gets bigger? What happens to the t-score? As the sample gets bigger, it gets
smaller.
Smaller. It gets, and what does it do in the case that I have a very large, you got to love this shit. They just kind of gave up at the end. The 5,000 freaking large. What does it become? It should look very familiar. It should look very, very familiar. What does it become? Does that look familiar to anybody, that number?
Z-scores.
That's a freaking Z-score. All right, Jeff. Calm down. All right. That's a Z-score. In fact, this whole last row, some of them should look familiar. One of them is a little bit different because it's a little more, actually, it's a little more accurate. So we used, remember 2.575? Didn't we just use that one earlier? 2.575? No?
That was for the 99% confidence.
Exactly. And why does it make sense then that this is here? Because 99% would be, what would alpha be for 99% confidence? How much is outside? There's 99% inside. How much is outside?
0.01.
Exactly. And see what the column is? 0.01.
I have a question. So when
Sure.
you wrote that n equals 7, was that just a random example like number that you put out there, or
Totally random example. So that would be in the problem. It would, I would have to tell you how big of a sample I took, of course, right?
right?
I always have to tell you how, what n is if I'm taking a sample. Yeah. So then I can figure out what degrees of freedom are, and so that I know when to stop. So something I want you to start to incorporate. This is the T-score chart, correct? But what lives on the T-score chart at the bottom are Z-scores. These are Z-scores. This is even better than the baby chart that's on the Z-score chart. Remember, this is even better because now I can find, if I want a Z-score, what do? I just go here, go to the right column, and I just don't stop. I just don't stop. There ain't no party like a Z-score party. All right, I'll stop. So if I want a T-score, I stop. If I want a Z-score, I go all the way to the bottom. And again, why does it make sense? Because what is a T-score's job? A T-score's job is to make the interval bigger because I'm not certain about the S I get. But the larger the sample gets, the smaller the T-score could be until it becomes the Z-score, because it's not necessary anymore to make the interval bigger. All right, let me let all that sink in. That's a lot. So, as happens very often in this class, the explanation of something is a lot more difficult to wrap your head around than the actual work required for it, right? Do you recall when we first learned central limit theorem and we're talking about alternate universe Florida and all this shit? And then what did it boil down to? You change the standard deviation and then everything else is the same, right? And you're all like, well, you confused me. I'm like, I'm sorry, that's my job. So let's do this. Let me activate this other sheet on here. Not surprisingly, I have a worksheet. What? Oh, where is it? Donde? There you are. Okay. So now, if you refresh your canvas, I think, and go back to Unit 8, you should see T-score practice showing up. So let's see what this thing looks like. Yeah, baby. All right, so let me open this up a different way. So again, is everybody able to find that on Canvas? Let me find, oh, where are you? Dadgummit, Jeff. Can't name something worth anything. Hold on, everybody. T-scores, where are you? There, no, is that it? Yes, it is, and it's all the answers, Jeff. Why don't you have a blank one? You suck. Hold on. All right, let's see. Oh, Jeff, will you ever learn? No, that's all you got, buddy. Oh, here it is. There you go. All right, here it is. All right. If I do this, can you guys see the t-scores now?
Yes.
Okay, I just don't trust it for some reason. And now you see the t-score practice.
Yes.
Thank you. Okay. All right. So let's do all right. So there's one that's kind of weird in here. Go ahead and try to do the first one. Let's see if you can do the first one. Don't say anything. Don't type anything. Just do it and hang on. So I should have asked you what alpha was. That would have been a good idea. Maybe I'll update this. Can somebody tell me what the degrees of freedom are? Degrees of freedom.
6 minus 1.
Good. Can somebody else tell me what alpha is?
.01.
Good, because that's 99%, which means 1% outside in the two tails. So that should be all you need to know to be able to find this in the t-score chart. Degrees of freedom is 5, and I want to go to which column for 0.01 alpha? Which column do I go to?
First column.
First column. So there it is. It's 4.032. Does everybody get that? Try to do this next one. Jeff, stop. Oh, good. All right. I'm walking on sunshine. All right, so what's the degrees of freedom on part B?
100.
Good. What's alpha?
0.10.
Good. So now let's see, we know 100 degrees of freedom. Alpha is 0.1. So which column am I looking at?
One tail.
Okay, that's weird.
Wait, are we looking at one tail or two?
You tell me.
I'm thinking two.
Yeah, because confidence intervals always create two tails. Now you could look at the one tail, but normally, so alpha's 0.10 because it's a 90%, right? Which means there's 10% in two tails. So I'm looking at this column. So what if you say instead, all right, 10% in two tails means there's 5% in one tail. Well, then you're in the same freaking column, right? Same column. That's beautiful. You can't go wrong. 10% in two tails, 5% in one tail, same column. And where am I supposed to stop in this column?
$90?
What do we say? What's the degrees of freedom?
Oh, 100.
Yeah. So I'm going to stop at 100. You guys get that? Is that all right? 1.66. So instead of using 1645 in the confidence interval formula, I would put a 1.660. That's what it does. Ooh. So the actual nuts and bolts of what this does is not going to be that big. Now this one's a little bit weird. Let's see what you guys think. Try to do that last one.
For the degrees of freedom, we're looking for t-score, are we rounding? Like, if it's 92, do we just make it 90?
Oh, well, that's the question. Right. So officially, what's the degrees of freedom? 92, right? Is that cool? And what's alpha?
0.02?
0.02, I love it. But the problem is, so I go to 0.02, and I'm supposed to stop at 92. What the shit? All right. So basically, what you should always do, this is statistics. You should always punish yourself. It sounds terrible. There's no better way to say it. You should penalize yourself for not knowing something. So am I going to make my t-score, am I going to go up to 100 or am I going to go down to 90?
90.
I'm going to go down to 90. I'm going to make the t-score bigger because there's something I don't know. Even if the degrees of freedom was 99, I would accept it if you went here, but you should technically go here. All right. And again, you got Jeff as a teacher, which means Jeff is not letting you use a lot of technology. Technology would get the exact t-score for every degree of freedom, and I don't give a shit, right? It does too much for you. So since we're using this weird ass chart, I'm going to have to kind of say, okay, let me make that 90. Oh, I already forgot. So in which case, I forgot which column I'm in. There I am. So we go to 90. I'm going to use this t-score, 2.368. Now notice what I say up here in the beginning for the t-score lightning round. Assume it's normal, and of course S is known. So somebody tell me, why were t-scores invented? What was it that made the Guinness dude, William Gossett, that was his name, William Gossett. What made him have to create t-scores? What was it? Does anyone remember? What's the whole thing that got this going?
Make the interval bigger if you're unsure about the S value.
Beautiful. If I don't know the standard deviation, if I don't know the population, so it's if I don't know sigma, I only know S. But also, as always, I cannot do shit unless it's normally distributed, correct? So in number one, I said, assume it is normal with S known, sigma not known. That's why it was a bunch of t-scores. Now look at number two. Number two opens things up a bit. Number two says the right answer could be a z-score, a t-score, or can't be done. So can somebody look through, let's see, like on 2A, what might you be worried about when you see n is 22?
It might
Whereas,
not be normal,
yeah, because it's not bigger than,
30.
but what does the very next thing say?
The population is normal.
So does that mean it's okay to have 22? Of course it does, right? When do I need the sample size to save my ass? When the population is either unknown or I know it's not normal. So is part B normal?
No, because the population is not normal.
What makes it normal though when they plot the
Because
means?
it's normal because it's over 30.
Yes. All right, so this is normal, so then I can do it. This one is normal because even though the sample size is too small, it doesn't matter. I don't need the sample size to save me. It's already normal. But what am I going to use? So then I know I can do something, right? So it's got to be normal. If it's not normal, I cannot do anything. A and B are both normal, so I can do something. What am I going to do in part A? What am I going to use? A t-score or a z-score in part A? Which one?
Score?
Say again?
The z-score?
Z-score, why?
because it's number disputed and sigma is known.
Sigma is known. I like it. Yeah, so it's normal, check, and sigma is known, check. So I can use a z-score. I like it. So take a minute and figure out what that z-score would be. Don't say anything. So it's 90% confidence level. You can use the t-score chart to find this, correct? What would alpha be?
And z-score will be 1.645.
Not what I asked.
Oh.
What's alpha?
0.10.
0.10. I love it. So when I go to the t-score chart, and at some point, I'm going to get somebody say, we want a z-score. Why are you looking at the t-score chart? Well, because z-scores live here too. So 0.10, I'm going to go here. And to get a z-score, I just go all the way down. And there it is. I like it. 1645, just like you said. All right. Now you guys do part B. All right, so in part B, is it Z or T?
T,
T. Why?
because the sigma is not known.
Good. Sigma's not known, only S. And of course, it's normal. What is alpha?
0.02.
0.02.
02. I like it. And what's my degrees of freedom?
38.
I like it. So now you know everything you need to know to get the t-score. So let's go see. Alpha's 0.02. Degrees of freedom is 38. Chiboo. So I get 2429. Is that what you guys got?
Yes.
Okay. All right. Now somebody who hasn't answered yet. What's up with part C?
It's not normal and it's less than 30.
So what can I do? What can I do?
It can be done.
Can't do it. Next. All right. So this would actually be a problem that you could do something with in stats 2, but you know, we don't teach stats 2 here. I'm sorry. But currently for us, we can't do shit. If it's not normal, I can't do shit. All right. Now go ahead and do part D. I'm not going to say a word about part D. You guys do it. Do it. I'll just sit here and wait. Don't say anything. All right, let's see. Let's take a look. Is part D normally distributed?
Yes.
Yeah, doubly so, right? It started off normal and sample size was big enough just in case. We're like, we don't need you, buddy. Normal check. Z or T then? Zort.
T.
T, I love it because I only know S. I don't know sigma. So then what's alpha? What's the degrees of freedom? What's alpha?
0.01.
Alpha 0.01.
101. And what's my degrees of freedom?
60.
60. I love it. So I know alpha's 0.01. Degrees of freedom is 60. 0.01. Go to 60. Kabam. 2.66. Oh, look at these guys. They're like, that always freaks me out. Anyway, sorry. 2.660 is my t-score. All right. So the last thing we're going to do today is number 3. We'll call it a day after this. By the way, I want to point something out. I'm going to erase this in a minute, but do you remember how this is the formula for section 8.1? You guys remember this? All right. Do you notice how Z goes with sigma in the formula and how T goes with S in the formula? Do you understand what I'm saying? You're not allowed to have notes. The formula is a freaking note. When do I use the t-score? When I know S. When do I use a z-score? When I know sigma. And of course, it's got to be normal, but you guys kind of with me out there? That's beautiful. That's so kick-ass. Isn't it awesome when a formula tells you what to do when? All right, which is basically what formulas do, but I'm sorry. So the first thing is you got to remember how to do this. You guys remember how to do this? Whoa. Okay. Do. Let's see. Hopefully you guys are working on that problem. Scheisse. Is the sample big enough? Anybody?
No, no,
Why is that not a problem?
because it says it's normally distributed.
Yeah, it comes from a normal distribution already. Good. So I don't need a sample size to save my ass. All right, so just to make sure you guys remember how to do this. So I put my data here. Don't worry about all this stuff that's from before. Here's all my data, right? How do I calculate the one variable stats? Where do I go? I'll tell you where to go, Jeff. No, stop. Where do I push to get the one variable statistics calculated?
Is it math?
Nope. It's close.
Stat.
Stat.
Stat 1.
Calculator.
Test.
Go over one. Right there.
Yeah, there it is. I want to calculate stuff, right? I don't want to test stuff. I want to calculate stuff. I want to calculate one var stats. My data's in list 1. I don't have a freaky list. Calculate. There we go. So does everybody get this? Now notice, I think I've pointed this out to you before. See how the calculator gives me S in sigma? Can I just pick sigma and pretend like that's all good? What was it that we put in? Was it a population or a sample?
Sample.
Sample. So what do I have to use?
S.
S. Why does the calculator give me both? Because the calculator is dumb. It's dumb. You dumb calculator. Man, I'm really pushing my luck. Technology is listening to me. All right, but it is dumb. It doesn't know. So let's write this down. Let me, oh shit, what the hell are you doing, screen? See, already it's like, what'd you say about me? Like, shit, damn it, Jeff. What have you done to yourself? All right, let's write this stuff down here. So I got that the mean 78.29, we'll say, and I got the standard deviation to be 15.724. Is that cool? Okay, I'll take that as a yes. Now, do you see how we got this? And we got this, and obviously we got this. What's n?
Sample size.
I think you said 7? Okay. So n is 7. We know x bar, we know s, and we know n. We just have to figure out what the t-score is. And I kind of gave this away, but why am I using a t-score, of course?
Because there isn't a sigma.
Good. We don't know sigma. We don't know the population standard. We only know the standard deviation from the sample. All right, so take a minute, figure out what the t-score is. All right, you know what alpha is, you know what the degrees of freedom are. What's alpha?
0.02,
0.2. What's the degrees of freedom?
6.
6. I like it. So now if I look at 0.02 and I stop at 6, 3.143. So now you just throw all the shit in. I know X bar. Oh shit, let me see. Where's X bar? Oh, I forgot there's a whole other thing. Don't worry about this down here. Look at that. Ooh, look at all that data. Oh, sorry. All right. I'm not even sure if it's on the one that's up on Canvas, to be honest. To be honest. Let's see, 78.29. That's the X bar. Give or take this many standard deviations. That would be 15.724 divided by the square root of 7. One big thing that happens is people will put the degrees of freedom here. But of course, the formula says n. N is 7. All right, let's see what we get. So I'm going to do the error first. Oh, yeah. Did anyone calculate the error?
5.9431.
No.
Oh, whoops, I missed the t-score.
Is it
Oh,
0.529?
say again, sorry?
Sorry, is it 0.5290?
No, I'm not sure what's happening up there. So we're just putting in 3.143 times 15.724 divided by square root of 7.
18.6792.
Yeah. Are you guys able to get that?
Yes.
Not that much going on here, right? It's just this times this divided by this. And now you subtract from this and you add to this, right? So it'll be, you're going to do this in your head, Jeff? Sure, why not? 59.611. Is that what that is?
Yes.
Dude. And then 96.969, I think.
Yes.
All right, look at Jeff. Adding, subtracting like he knows what he's doing. Now look at that pathetic. Why is that pathetic? What is this interval trying to capture? I love it. That was awesome. Every class needs a humming interlude. So, why is this pathetic? What am I trying to capture? What is this confidence interval trying to capture? Bunch of grades. It's trying to capture the
True mean grade.
mean grade. So this is saying that we're 98% confident that the interval 59.6 to 96 point, basically 60 to 97 contains the true mean grade. How useful is that information? It's anywhere from 60 to 97. It's like
Not really useful.
not useful at all. Now, of course, why is it not really the interval's fault? I mean, how big was our sample? Do we have a very big sample?
No.
No, our sample's pathetic. So of course this is going to be really uncertain, right? So if somebody just told me they got an average of 78.29, I'm like, okay. But then they told me this instead. They said, well, we think the real average is somewhere, but I would be like, so you're basically saying you don't know shit. Yeah, that's what we're saying. So this is much better to tell somebody than this. This is being much more honest than just this. That's the most fundamental reason we make confidence intervals, is to honestly communicate what we know. All right. Oh, let's see. I don't know about you guys. I think it's enough. What do you think? Is that okay?
More if you want.
Huh?
I can hum some more if you want.
Thanks, man.
I left my mic unmuted.
That's fine. Considering other things that I've heard from unmuted people, that was nothing. That was completely innocuous, so it's all good. Okay, guys, that's enough. So let me know if you need to hang out afterwards. Otherwise, go out in the world and have a good time.
Bye. Thank you.
Thank you. Bye-bye.
Time to sow chaos.
Thank you.
Bye.
I had a quick question.
Yes.
So, when we write S, that means the standard deviation, or
Yes. S is which standard deviation?
wait, what do you mean by that?
Because there's sigma and there's
Uh-huh.
S, and they're both standard deviations.
So it's the standard deviation for the t-square.
No. So like mu and x bar are both means, right?
Right.
X bar is the sample mean. Mu is the population mean.
Got it. Okay.
Sigma, population standard deviation. S, sample standard deviation. So like a population gets Greek letters because it's whoa, and the sample gets our letters. Yeah.
Okay. Got it. Thank you.
Whoa. All right, guys. I'll see y'all later.